friends, today we are going to study about quadratic hashing. You must have been watching the hashing videos that I am uploading, and you can link my videos to understand the complete concept of hashing. Basically, hashing is a technique which is used to extract some data from some databases, and this technique is one of the three different types of hashing in which we efficiently extract data or add data into databases. Most of the companies are having names of the students, and we want to know the particular name of a student, so it is not always easy to look for each and every name. So normally we use the registration number as a key. Similarly, if we want to search a medicine, then we use certain numbers to search those medicines, so those numbers serve as key. So similarly, in this same manner, we enter the information in databases, and with the help of keys, we now normally search those data, or we normally extract those data out of those databases. So right now I'm going to teach you that how do we perform quadratic hashing, how do we use the hash function in quadratic hashing, and how what are the advantages and disadvantages. Okay, so let's consider that we are given the hash function k mod 10. There are many different types of hash functions. For example, there can be k mod 10, k mod 20. There can be many different type of functions in which you can split and half do folding, but right now we are using k mod 10. So by using k mod 10, we are given with the keys 42, 16, 91, 33, 18, 27, 36 and 64. So let me apply one by one. 42 mod 10 is equal to 2, 16 mod 10 is equal to 6. Similarly, I am finding mod for 91, 33, 18, 27, 36 and 62. So what I found that for first few functions I am getting unique numbers. So with the help of these numbers, I am inserting these numbers into this hash table. Why I draw a hash table from 0 to 9? I already told you that whenever you have a mod 10, the hash function is taking a mod 10, then 10 is your n, so you do n minus 1 and you make a hash table till 9. If you had a k mod 20, then 20 minus 1 you had to make a table till 19. So that is the basic thing. Okay, so first few numbers will be inserted as it is. 42 is inserted into location 2 into this data table. 16 is inserted into location 6. So whenever someone is asking you for this number 16, or for this student who has a registration number 16, you will simply go and look into the sixth entry of this database. Similarly, 91 is stored in location 1, 33 is stored in location 3, 18 is stored in location 8 and 27 is stored in location 7. But what should we do for 36 and 62? Because 36 also wants to be stored on 6, and we already have data at location 6. So one method or one option was to make a linked list, which we studied in my previous lecture. But right now we do not want to make a linked list. So what do we want? We want to resolve this collision with the help of this function, which is called quadratic hash function. This function says that whenever you have a key, and that key has a collision with a previously allocated location in the database, then you will use an I plus this I square. This square is representing that this is quadratic hashing. If there was no square, then it would have been linear hashing. But right now, since we are doing quadratic hashing, so that's why this I has a square. So how do we do this? Let me show this to you. Okay, we are using this quadratic hash function, and now I square will be used, so we will have jumps. All right, we are not having I, simple I raised to the power 1, we are having I square. So we are not going to move linearly, like we will not simply go from here and check there. We will have jumps, and how large the jumps will be, let me show it to you. So first of all, I'm going to resolve the collision for this number 36. So this function means that in the position of k, we will simply write 36, and we know that the mod of 36 with 10 is 6. So it comes out as 6. And what will be in the position of I square? First of all, I say that okay, I just want to have a jump of 1, and I just want to do one iteration and check that okay, if I'm not going to store in 6, then what can be the next location. So I put 1 square and this becomes 7. So mod of 7 with 7 mod 10 is of course 7, so we have to check in the position 7, but unfortunately there is already a number stored in 7, so it is already filled. So we have to now try with I equal to 2, right? So I am going to put 2 in the place of this I, and there it will still be 6 because mod of 36 10 36 mod 10 is still 6. It is not changed, it will be just the same number, only this i's position is changed. So this will be 2 square, so 6 plus 4 will become 10. Okay, so 10 mod 10 is 0. Always remember that the formula says that whatever this summation is, you have to take mod of 10. You will not use this summation as it is. So 10 mod 10, it is equal to 0, and look at my then go and look at the table. The 0 position is empty, so I took this 36 and instead of storing it onto the 6th data entry location where I was having a collision with the already stored data, now I'm going to store this 36 into the position 0 in this database. So one of my collision is resolved. Okay, now let's come on to the second data entry, which was having a collision with another data entry, because there was a data entry 42 which is already residing in location 2 of this database, and 62 also wants to go into the same location. So we are having a collision. So now let's perform the same operation for this number 62 as we did for the previous number. We are going to use the quadratic hash function. First of all, we assume that I is equals to 1. So at 62, we already know that the modulus 10 of this number is 2. And when we put I as 1, then it becomes 3. And 3 mod 10 is 3. But just look onto your table. Now you see that on location 3, there is already a number stored on location. So since this location 3 is already occupied, already data entry 33 is residing, so we have to perform another iteration. This time I'm going to place I equal to 2, and when I put 2 square, then it becomes 4, and 2 plus 4 is 6. So if I take modulus of 6 with respect to 10, then it's 6. Let's go and check onto the location 6. Oh my god, unfortunately 6 is already occupied, so I cannot store this new data entry 62 in this location also. Let's calculate with I equal to 3. So 3 square is 9, so 2 plus 9 is 11. 11 modulus 10 is 1, and you can see from this table that data entry 1 is also having an entry. So now we are going to check with I equal to 4. 4 square is 16. 16 plus 2 is 18. 18 modulus 10 is 8. 8 is also not the right answer, because you can see from this data table that 8 is also filled. So this means that it is of no use to keep checking. We can keep checking, but normally in such situations where you can see that half of your table is already filled, only there are 3 locations that are empty. Normally in such a case we have to do a lot of iterations, and the procedure becomes complicated, the time complexity is increased, and we are not very easily able to fill this data. So this is all about the procedure of quadratic hashing. Yes, quadratic hashing is very useful when you want to fill data and you do not want to utilize some extra space as you normally do in the case of linked lists. But the main issue is that you have to when you have large data structures that you need to fill in, and your table is almost half of it is filled, then in that case it is not very easy to fill the numbers into the table. Continue it further. For example, if we are going to take I equal to 4, then we can still say that it will become 2 plus I equal to 5. Sorry, we already did with 4. So I equal to 5 will become 25, and 25 plus 2 is 27. So I'm going to do 27 mod 10, and it will be 7. So you see 7 is still filled. So now let's try it with I equal to 6, and if we try it with I equal to 6, then 2 plus 6 square is 36. So it will become 38. 38 mod 10 is 8. So you can see that 8 is already filled. Similarly, if I am going to try it with 7, then 2 plus 49 is equal to 50, and 50 mod 10 is 0, and 0 is 0 is already filled. So you can see from here that we have done a lot many iterations and still we're not able to completely fill all the data. So if I talk about the disadvantages of this quadratic hashing, so first of all, you say that searching the data or inserting the data has a lot of complexity, and this complexity is O of the order n. Similarly, you do not have any guarantee, no guarantee. You do not have any, you do not have any guarantee that your all the data is going to be filled. So you do not have any guarantee of filling all the data or finding the slot, in other words. And if I talk about advantages, then what do you think? What are the advantages? Primarily, it has two advantages. It does not need any extra space. You can see that you have filled this 36 in the same space, in the same data structure. You're not making any linked list. So this is, yes, this is one advantage of this quadratic hashing. And it is not doing any primary clustering. What is primary clustering? Primary clustering means that if you have some data points here, so in the case of linear probing, the probability that the next data entry will come here is very high. For example, if this is a table of entries 9, so generally the probability of any new number coming into any of these slots should be 1 over 9, right? But it is not the case. See, if you have this slot empty and you have a new entry, so and all of these entries are already filled, so the probability of the new number coming into this entry will not be equal to 1 over 9. It will actually be equal to 1 over 9 plus 1 over 9 plus 1 over 9 plus 1 over 9. Why I'm saying this? That for example, if the number is if that new number is lying over here, still you will probe it linearly and you will come down here. Similarly, if your new number is coming over here, this slot is filled, so the number will probe over here, and over here. So for all these four numbers, and this fifth itself will lie into this entry, this space. So that is why this the probability of lying into the next empty slot right after this cluster is high. It is 5 over 9. It is not 1 over 9. So this thing gives rise to primary clustering, and whenever there is primary clustering, then it becomes very difficult to search a number. So the search time complexity increases. So in the case of quadratic probing, so since we are not moving linearly, so we are not having primary clustering. This thing is not happening here. So this is an advantage of quadratic hashing, that we are not facing the problem of primary clustering. So these are the two advantages of quadratic clustering, and I already told you that the disadvantage of quadratic clustering is that you are not able to fill all the data entries. There is no guarantee that all the data entries will be filled, as you have just seen in the example that the last point 62, although we made multiple efforts, but this point has not been filled into the table. With this, I am going to complete my topic of quadratic hashing. I am hopeful that you understand what is quadratic hashing, and if you have any questions, you can write them down into the comment section. Thank you very much. Allah Hafiz.